Before we start, we need to talk, you and me. For many years now, we work together as a team. And I think we always did a good job. A clean job. But over the years and now the last months, I see clearly you don't perform as well anymore. I see that you're slowing down. You leave traces. And I see that you even lose your hair. Now I know, I lose my hair too. But your hair is essential to your job. Mine isn't. Don't try to hide in a corner. It's you I'm talking about. I mean, look at you. Almost nothing left. No wonder you don't perform anymore. I mean, even here. Nothing left. And I think it's time for replacement. I think you don't get it, do you? If I say replacement, it means that you're fired. Yes, look at this. Brand new and all soft and shiny. Let's give it a go. Shit! Hey, come back. You're back in service. This bolt holds the engine in place in a tram. But of course, everybody knows it. This thing needs a crown nut because there's a hole to put a split plinth. And we spend a lot of time in the depot looking for one, but no, can't find. Which means, let's make one. This is a 14 TPI thread. And I had to clean it up in the lathe because I suppose someone hammered it out and it was completely mashed up, and now it looks again more or less like a thread. But because I don't know a thing about Whitworth threads, I did a little bit of research on the internet, and they tell us, if it's correct of course, that the 14 TPI thread should be normally a shaft 7/16. And this one is of course way bigger. Now I work in millimeters, and if I measure it, the thing is 19.7 external. But what I need to know is the internal. So I will do a little bit more research. But first I will cut the hex in this little thing here. And I would like to use my homemade hex block here on the shaper, but of course this diameter too small to take my workpiece. So I will use you another time. Which means I will do it here on the milling machine using a dividing head. The official way to hold the dividing head in place is of course using this thing here, which means I install this and then I can tilt in horizontal or in vertical position. Here are the degrees and here are degrees. And of course the bottom of the dividing head comes here. But all combined, it is very, very heavy to handle. And that's why some time ago I made these 3 little feet that I can screw in the bottom and position exactly where I want, because this is of course a circular bottom thing here. And then make these 3 little clamps, and I can install the thing in whatever angle I want. And of course I can also move the table in whatever angle I want. And this is a lightweight idea. For me, much better. It works really well. This thing is now 2/100ths out of center. Normally not good enough, but for a hex on a bolt or a nut, it will do. And I would like to make the hex the same size as this one, of course. And to do so, I need to cut down 2.5 millimeter. I installed a 16 millimeter, what is this, a 4-flute cutter, and let's see what happens. Let's make a hex. Yep, good. I took the part out before finishing it. Here you can clearly see the line between the first pass and the second pass. And what the camera doesn't show is the difference in height. And when I rotate a little bit more, while cutting, I see that there's something going wrong. And here we can see that this surface was recut a second time, which is of course not the way to go. And this side higher than this side, and here there's a little shoulder. While cutting, I could see that there was more and more vibrations. Something wasn't right, but I couldn't figure out what. But at the end I did, and it's the faceplate that holds the chuck is not well seated on the dividing head. Here I can put in I see on my camera, because I can see what I'm doing here, of course. Here I can put a feeler gauge in it. So I will retighten this all nice and fit together and then start again, and I will bring you back when it's done. And this is what I wanted to make, not this one. So I just started again on the other side and then cut a piece off. And I think now it's time to make the bore. And after a little bit more research, I found this little chart here. So now I know that I need to drill and bore a hole in here, diameter 17.38 over to the Celtic. I pre-drilled my part diameter 16 and I need to bore it out to, check my blackboard, 17.38, so 1 millimeter something more. But hole 16 and my cutting tool has also a width of 16. So let's see if we can get away with it. I think it will work. That's easy peasy. That will do. To cut small internal threads like this one, I mean in a small bore, normally I use this nice little thread cutting tool. But This one is a 60-degree cutting tip and I need 55. I installed a 55 with an insert in here, but because it's a tiny bit bigger, it will rub here on the shank. So I think it's time to adapt. I reinstalled the thread cutting tool and I tried, and now I have more or less 2.5 millimeters of free play inside the bore. And I think I'm ready. No, not yet, because this is an imperial thread. I need to change gears. Right, all set. Let's cut threads. I didn't video much of the thread cutting because of course all the action happens inside and there's nothing to see. But I think it came out very well. And now it's time to work on the other side of the nut. Let's see what we've got here. Of course, a hole. And if my nut comes over here, I think I need to leave space for a washer and even a little bit more space. That's not easy measuring. Something like this. Let's give this nut 10 millimeter and a crown. The total, I will make it, for example, 16, and then the crown will be 6. All that's left to do now is to cut these little granulations for the split pin, of course. And I installed my part back in the dividing head, and I see that there is here a clearance problem. The plan is to nibble every time a little piece away and go deeper and deeper, but this is not gonna work. So I will cheat a bit and I will use a drill chuck. One of the many reasons why we don't use drill chucks for end mill is that while cutting there is a side load on this whole system here, which means here is my end mill. If I push this way, all this will be forced, of course, in the same direction. And because this one is held together with a taper and only a taper, this taper could come loose. It's not designed to take side loads. This old chuck here is held together with a thread, so it's threaded in like a bolt idea. And this one can handle side loads. It's not made for it, but it will work. I left the bottom part a little bit longer on purpose, because I don't know if there will be a washer here between, or maybe it is a bushing when I see the wear on maybe it is pushing on a bushing, pushing on a bush. So I don't know. And I think it's of course easier if I need to cut a piece off than start again and make it bigger. So I left it a little bit bigger. Oh, and by the way, I also fixed my new broom, which means this one